One who sent me that brass 464 last year to fix up has another interesting project. This year it's an F7 with a shell made by Globe, later Athearn, which has had some detail and custom work done to it. But what's really interesting about this one is the chassis underneath it, which is a full Lindsay F7 chassis that I had never even heard of before. I know that they made a much simpler powering kit for the Globe F7 that just used one of their standard powering trucks in back, and then had a weight that attached to the back, and then the back of the plastic fuel tank. But this here is something else entirely. It's a full metal chassis with 8-wheel drive. You can see a flywheel inside of there. So that's a chassis design that I think I've seen it on a couple brass models before from Chemtrin, but never on an F7 power chassis before. So let's get to work on this and see exactly what's up with it. So whoever put it together originally just has this screw on the back from the look of it to keep the shell on. And that lifts off, and that's a pretty large motor there. It's definitely got a different end casting that allows it to be mounted to the frame. And it's got this big fan on it to help keep the motor cool. So this is definitely something quite a bit larger than what you usually see from Lindsay. Spring drive universals going to each truck. Seems like things are turning freely enough, so I think this just needs some tune-up work, figuring out where a few parts go. He also sent me a bag of some extras with a few screws and washers he couldn't quite figure out, as well as a connector to help him finish with his little LED lighting project here. So let's see what we've got. We've got these end pieces that help to hold up some wiring and kind of replace the pieces that came in the original plastic Globe chassis. See, there's a drawbar there. I'm assuming that connects to another A unit that goes behind it. I don't know if he still has that or not, so I'll just leave that in place. Leave a coupler up to him if that's what he wants to put on there. See some interference there from some of the wiring, so I'll get that fixed up. Let's see, I'll just take off this front plate here. Okay, just a couple wires holding that. So I'll remove that entirely for now. Come on, come on. That wire must be wrapped around there. This looks like original factory wiring here, and it seems like it was really thoroughly wrapped around those contacts, so I'm just gonna clip that off actually. There's plenty of wire left, so I can just do a bit of stripping from the wire and then resolder it later. It'll be totally fine. Let's see, what else we got here? Oh, well, I guess I should have looked a little closer. There's just a screw holding that to the side. That would have made it easier. Oh well. Looks like that might need a small Allen wrench or something to disconnect it. I wonder if I have anything that can fit in there. Sometimes you can cheat a little bit by using Torx drivers instead of Allen wrenches. This is the smallest one I've got. Oh, yeah, and it looks like it's unscrewing. Very good. So that will allow me to remove the truck. Yeah, that was just on there a little tight. Okay. So yeah, there's the Lindsay geared truck. Definitely a later design from them. Something you definitely don't see often. Now, let's get in here and see how they built this thing. Like I said before, I've only seen this maybe a couple times on some Chemtrin brass units. I've never seen any actual documentation, diagrams, or anything on how they're actually built, or even what kind of availability they had, or for how long. So I'm guessing this here is an especially rare piece. Okay, pull off that end cap. Just a simple tower transfer gear system. All metal gearing, that's nice. Let's see. Now, the owner of this, he did already do a little bit of work on his own, just doing a bit of cleaning and relubrication, but he wanted me to go ahead and give it a full tune-up, so I'll clean it up again and add more fresh oil in place of what's already there. Might as well just make sure it's all completely fresh. Attachment system for the globe side frames. Then their standard geared axles. It looks like this has their standard 13-tooth helical gear on it. Alright, so there's the disassembled truck. Let's wipe that out a little. It actually seems pretty clean for the most part. Okay, I wasn't really too thorough on the cleaning there, just a quick light cleaning to get some of the grease and oil out. But since it was already mostly fresh, might as well get out these other parts from the bag. See what all is in here. Yeah, so we've got a bunch of washers. See a piece of a broken globe side frame. Some connectors for the LEDs, I'll work with that later. Yeah, there are quite a few metal washers here, so I'm guessing most of these go to these worm shafts to take out some of the back and forth motion. So let's see what kind of a fit we've got in here. It's quite a bit of back and forth motion, so those are definitely thrust washers. So we'll start by putting 2 on each end. See, this is the right way for this plate, right? Oh, no, it goes this way. Almost had that backwards. Have to watch the countersinks for those small screws. If you put it on backwards, they won't fit in there right. Okay, seems like that took out the play from the system. There's still just the tiniest bit of front and back movement, which is exactly what I'm wanting here. Allows it to turn freely without being able to wobble back and forth. Okay. Now as for the other gears and shafts, well, how many washers do we have here? 5. This drops into here. That middle gear doesn't need any thrust washers because it doesn't move forward or back. And let's see, the upper gear still has 1 left on it. Just jam a piece of tubing on there real quick so that I can at least turn it by hand. And that gear is moving back and forth quite a bit. So I'm not sure if it's actually supposed to be doing that. Okay, well that should actually turn smoothly once I have the plate actually screwed in place. I just need to add a little oil to this one here since I can't access that shaft from the other side, I don't think. Actually, I should also put the grease onto the gear while I have that out. And since the gears all have the same number of teeth from the look of it, it's best to get that grease spread all the way around so that none of the teeth get missed. A little bit of oil here. Seems pretty smooth. I don't feel any binding at all. Seems like it's actually pretty quiet too. Of course, being a Lindsay drive, I fully expected the gears to be good quality. Just a little more oil in each of those. Now, as for the wheels, it's one insulated, one grounded. Let's see, the other truck has the grounded wheels on the right rail, so I'll make sure this is on the left rail. Just like this. Yeah, to see how that's doing, let's hook up this smaller Lindsay motor just to check things out. This is a motor that I have on hand but haven't used for anything yet. I'm sure you'll see it in a later video. Bind. Must have been a false alarm. Okay. That is surprisingly quiet for a gear tower drive. I think that's about all this truck needs. So I'll do the same with the other truck. I think we should also take a look at this motor. So this has 3 screws holding it in place, as well as full vibration dampening padding, top and bottom. Oh, something fell out of there. Support block, rubber support. So that means there's one more. Yeah, there it goes. So those hold up the motor. These are really soft, by the way. That will definitely dampen vibration. Okay. And a washer from each of those. So there's the metal chassis. It's actually fairly light. There's not much metal there. I think that's just because they were trying to make room for all the other stuff in there. And of course, with it being an F-unit chassis, you can add weight easily enough. But yeah, there's the motor for this one. Let's have another look at that other one. So this motor is about the size that you would get in one of those self-powered trucks. This might be the size for the maybe smaller switcher trucks. Even so, not too far off from the other ones I've used, but look at the size difference there. That is just, this is really huge for a Lindsay motor. On top of that, it's got that big brass flywheel. It's got that fan to keep it cool. Flywheel is held in place by a set screw. Same as those spring universals. And let's see, I've seen these universals in some of their documentation before. They, on their PA chassis, which had the motor hanging off of the truck like this, they had the spring universal coming off from the motor to power the other truck, so that it would have 8-wheel drive with the middle axles just being free floating. I've never gotten to see one in person before just because of their rarity, but I have at least seen them in the catalogs on HO Seeker. Okay, let's see. Yeah, with that screw loosened, that just pulls off. Still kind of tight. Yeah. Okay. Then there's the fan, just a piece of stamped out metal. But Lindsay's motors do tend to run kind of hot, so that's a good idea putting that in. So what kind of running quality does this have? So going free, that's about 0.4 amps. It's very smooth. I feel almost no vibration at all from this. So that's really some top-notch engineering to put this together. And even at the lower speeds, it felt nice and smooth because of that 7-pole skewed armature. And I don't want to mess anything up here by pulling it apart. And the commutator actually looks really pretty clean too. So I don't think there's really any work that I need to do on the inside of this motor. I'll just add a touch of fresh oil to those bearings, and that is it. This doesn't need anything else. It still may not be quite the low speed you can get out of some of the most modern motors now, but that's still really impressive for something from the 50s. Now about this fan here. So that fits onto the flywheel. But I don't want that coming loose, causing problems, rubbing against the motor casing. Seems like that's the correct alignment, or was it on this way? No, it was the other way. Okay. Edges of these fan blades are pretty sharp, with it being just stamped out metal. Okay, I'm going to put a little glue on here just to make sure that fan doesn't come off at any time. Looks like they hammered some little notches in there to help keep it in place, but still came off anyway. Just kind of twist that around a little, work in the glue. Here we go, a little brass pulley I got off of something else. I'm just going to put this in the vise real quick and see if I can press that fan on at all, so it's not just the glue holding it. I think that'll be all right. Press that back on. That's a tightly built motor too. There's almost zero play in that shaft at all. Turns nice and smooth. Let's see how they got the balance. My other Lindsay flywheels have always been really well balanced. I'm pretty sure they lathe turned them. Yeah, that feels nice and smooth. Oh, something's slowing it down. I think it drifted a little. Let's see if I can fix that. Move the flywheel just a little away from the motor instead of pushing it all the way on. That should be better. Try that again. Oh yeah, much better. Coasts pretty well too. And I can definitely feel that fan moving some air over the motor. So that'll help to keep it cool enough to run for at least a fairly decent period of time without having to take too many breaks. And the balance of that flywheel is perfect. All right, so now to get the motor back on, I'll start by putting the rubber blocks and screws back in place. And I think these washers actually go to the motor mounting screws. So that's where they came from, because without them, the rubber pads on the bottom actually can't stay in place very well. So, washer on each screw, then a pad. One washer was missing, so I just grabbed a brass one out of my bin. So one of those for each of these holes here. Rubber pad just kind of fits firmly inside. Has a nice flush fit there for the most part. I'll work that in a little bit more later. So then the other pads go right here, with one more small washer on each one, just to help support the motor. Okay, so place the motor on top like that first. Then hold that on, and I should be able to screw these back in. Yeah, this is working. All right, so because of how soft those rubber blocks are between the motor and chassis, how tight you get the screws can change the alignment of the motor. So I only have those in sort of lightly for now. I can adjust them a bit later to make sure that the motor is as well aligned as possible with the trucks. Yeah, you can see there it has sort of a soft mount. Has no problem staying in place. And those washers will keep the rubber pads in place. I feel almost zero vibration through the chassis. Now, let's get the trucks back on. Actually, before that, I should put these end pieces on, because they are sort of blocked by the trucks. Actually, before that, I should put these universals on, because they're sort of blocked by those end pieces. Okay, now I can put the truck back on. I'll start with attaching the truck, and then I can worry about the alignment of the universal. Okay, that's on. So the spring pulls just slightly on that. Not enough to cause any traction issues. That seems nice and smooth. Okay. This one I think I can pull onto the motor just a bit more. Yeah, that'll be good. One more quick test before I start getting things wired up. Everything's working nice and smooth. This doesn't have the lowest current draw. Full speed there, that's drawing about 0.8 to 0.9 amps actually. So that's a good thing there's a fan on this motor. They were built with torque in mind instead of efficiency. It's one thing I've noticed about all the Lindsay motors of all sizes. They tend to have high current draw under any load. but always smooth runners. And as for the motor alignment, seems like I've got that just fine, so I don't think I'll be doing any adjustment of the screws down here. All right, the trucks are wired back up. Now before I add the lighting back onto there, I just want to take this over to the layout and see how the thing runs. All right, let's see how it does. And I haven't cleaned the wheels yet, so I wouldn't be surprised if there are a couple little electrical issues here and there, but it's starting up. Running nice and smooth. Not exactly silent. Yeah, that was definitely a really smooth runner. Put that up to full speed. It's doing just fine. It draws about an amp at that speed too. Not much I can do about that. This is about as free running as it's going to get. Like I said, these aren't exactly efficient motors. They were made to have a lot of power in a small space. Okay, so I gave the wheels a quick cleaning, and then I wired in the connector here so that the headlights can now just be plugged in or unplugged if any maintenance is ever needed. And I also bent the terminals from the LED a little more sharply, so now when that is mounted there, it shouldn't block any movement at all from the truck. Let's make sure that works. And there they are. So let's just get this screwed back in place. Okay, that is on. Let's make sure I got the alignment right with the shell. Let's see. I think I can put that just a touch lower. Okay, that looks about right. Now let's see, which screw was it that was holding this to the back? I think it was just one of these short ones, maybe? Yep, looks like that was it. Okay, so I think that's about all the work there is for me to do on this. There are just a couple screws that were in the bag. I looked to find if there were any possible locations for those, but didn't really come up with anything. And I see a couple threaded holes here, but I can't actually see anything on here that they would attach to, so maybe they're just extra screws from something else. Well, let's get this on the layout one more time and see how everything's looking. Let's see, let's just power that on. Nice light from the LEDs. So it looks like I got that wired right. It's running along nice and smooth. That's 8 volts right there. It's a fairly realistic speed for an F unit. And fast free. Running 0.8 amps. And that really is a really smooth runner. Takes off nice and smooth. I wonder how it does for low speed. Let's check that out real quick. Oops. mean, maybe it's not quite as good as the speed control on some of the most modern diesels, but for something from the late 50s, that is fantastic. So it's a smooth runner, super well engineered with all metal gearing, 7-pole skewed motor. This chassis really is really ahead of its time. That's some fantastic engineering in there. Honestly, I think the only downside at all is just how much current the motor uses when it's running. So that'll definitely draw more than an amp pulling a load along. But again, it's got the fan on there, so that'll help to keep it from overheating, at least for a little while. I still wouldn't run it too hard. Give it a break now and then, let it cool down. And since this does just use the standard Globe F7 body and truck side frames, there's quite a bit of damage around this one, of course, but that means that it's really easy to replace it with a brand new good one. Even the new Athearn shell would work just fine, since Athearn shells are the Globe shells. So this really was an interesting one to work on. I've never seen one of these chassis before, didn't even know that they made this one, so that's gotta be a rare unit. Honestly, it's kind of a shame that this wasn't more popular, because I mean, of everything I've seen from this era, I've never seen a chassis that was this well engineered. I mean, even the tower gearing is some of the quietest I've ever come across. Most of the noise you hear comes from the motor. I mean, you can hear a little whine from the gears, but it's not bad at all. And that's just a fantastic chassis. So to the owner, you've really got a great find here. Definitely one of the rarest Lindsay pieces I've ever come across. So I'll get this on back to you as soon as I can. And I hope you enjoy running it.